Hi friends, today we're going to talk about trigonometry. This is all about right triangles. So in a right triangle, the side opposite the right angle is called the hypotenuse, and the other two sides are called the legs. When you're given an acute angle, which remember is an angle less than 90 degrees, so the angle that is not the right angle, the leg that is part of the acute angle is called the adjacent side, and the leg that is opposite or across from the acute angle is called the opposite side. So if we look here, part of this got cut off, that's C and B. So which leg is the hypotenuse? In this case, it's leg Y because it's across from the right angle. So we always label the hypotenuse first. And now they want to know which leg is opposite of A. So if I look at angle A and go across the triangle, that's supposed to be a Z. Leg Z is opposite of A. Which leg is adjacent to A? That means the leg that's touching angle A but is not the hypotenuse. So that's leg X. Which leg is opposite of B? If I go across from B, that's side X. And then which leg is adjacent to B? Again, it's the side that's touching B that's not the hypotenuse. So it is side Z. Let's look at this one. Which leg is which side is the hypotenuse? If we go across from the right angle, we can see that side Q is a hypotenuse. Which leg is adjacent to L? So if we look at angle L, we already know that side Q is a hypotenuse, so that can't be my adjacent leg. So it has to be leg P. Which leg is opposite of M? So if I look at M and go across the triangle, side P is opposite of M, but adjacent to L. And then it says which leg is adjacent to M? Well, M is made up of Q and R, but Q is already our hypotenuse, which means R has to be the leg adjacent to M. So the hypotenuse is across from the right angle. So that has to be side G. Which leg is opposite of C? If we go across our triangle here from C, we get leg O. Which leg is adjacent to C? Well, I know that C is made up of D and G, but G is already the hypotenuse. So D has to be the adjacent leg to C. Which leg is opposite A? If we go across our triangle here, that's leg D. And then which leg is adjacent to A? A is made up of O and G, but again, G is already the hypotenuse, so it has to be leg O. There are three main ratios that exist if you have a right triangle. That SIN means sine is the opposite over the hypotenuse. That's what this means here. Sine is opposite over hypotenuse. COS means cosine is the adjacent side over the hypotenuse. And then TAN means tangent is opposite over adjacent. And the word you can help you remember that is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The steps to do this, you want to circle whichever angle they're asking you about. From that angle, you can label the hypotenuse, opposite, and adjacent sides, and I would label them in that order. Write out the ratios, plug in the numbers, and then simplify if you need to. So let's look at some examples here. So again, we have SOHCAHTOA. And they're asking us about angle A. So from angle A I know the hypotenuse has to be 13 because it's across from the right angle. The side that's opposite of A, if I go across A here, if I go across a triangle, that is my opposite side, not adjacent, opposite side, which means the last side then needs to be my adjacent side. So sine we know is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So plugging in what we know here, I'm going to put in 5 for the opposites, 12 for the adjacents, and 13 for the hypotenuse. So this would be 5 over 13, which cannot be simplified. Cosine adjacent, which is 12, over hypotenuse, which is 13. That can't be simplified. And then tangent is opposite, which is 5, over adjacent, which is 12. And that also cannot be simplified. All right, we're going to do the same things here, but with angle B. So again, we have our SOHCAHTOA. We're talking about angle B. The hypotenuse has not changed. That's still 13. But now if I go across angle B, my opposite side is 12, which means my adjacent side is 5. So again, sine is opposite over hypotenuse, which is 12 over 13. Cosine is adjacent over hypotenuse, which is 5 over 13. And tangent is opposite over adjacent, which is 12 over 5. And we'll leave that as an improper fraction, meaning don't turn that into 2 2/5. We would prefer it to stay as a fraction, but a simplified fraction, and all of these are simplified. All right, we'll write our SOHCAHTOA. And they're here talking about angle N. I know that because these all have N's. Hypotenuse is across from the right angle. The opposite is across from our reference angle, which is angle N. And then the adjacent is the side that's left over. So sine opposite over hypotenuse, which is 6 over 12, which we can simplify to 1/2. Cosine is adjacent over hypotenuse, which is 3 over 12, which we can simplify to 1/4. And then tangent is opposite over adjacent, so 6 over 3, which we can simplify to 2 over 1, or you can just call it 2. All right, here our reference angle is S. We'll write our SOHCAHTOA so we don't forget our ratios. Hypotenuse is across from the right angle. Opposite is across from the reference angle. And adjacent is the one we have left over. So sine opposite over hypotenuse, 3 over 12, which simplifies to 1/4. Cosine is adjacent over hypotenuse, 6 over 12, which simplifies to 1/2. And then tangent is opposite over adjacent, which is 3 over 6, which also simplifies to 1/2. All right, friends, so that's all we have for you today. Please reach out if you have any questions. Bye-bye.